In the last lesson, our goal was to focus on the exponential function, basically all the different properties that you can work with when you're given the equation, and then we went into graphing it and all the different transformations of the graph. So what we're going to do in this lesson is actually focus on its inverse function, which is the logarithmic function. And we're going to learn about some properties of it and then learn a little bit more into the graphs. So here with this first example, the first thing we want to do is just express both the 2 to the negative fourth equals 1/16 and 32 to the 3/5 equals 8 as the log equations. Right now they're in exponential form and they want us to put it into log, so that way you can kind of see how the two functions, which exponential and logarithmic, actually tie in together. Alright, so the first thing we want to do is focus on our base. With this example of 2 to the negative 4 equals 1/16. Okay, to put this into log form, start with your base. Your base here is 2, so right away I know it's going to be log base 2 because the bases have to match up. So the question is, it's going to be log base 2 of something equals something. And so what goes in this parentheses right here? What goes in the parentheses is what's on the other side of the equation, is 1/6. So log base 2 of 1/6, and then come back and grab your exponent, equals negative 4. And then you can check. 2 to the negative 4 equals 1/6, or I'm sorry, 1/16. Okay, so let's put some ones back in there. All right, on the other example, you have 32 to the 3/5 is equal to 8. Okay, well, let's go to our base. Our base is 32, so it's also going to be the base for the log. So log base 32 of something is going to equal another number. Well, you go to the other side of the equal sign, which is 8, to go what's in the parentheses, and your exponent's always what's going to be what it's equals to. So 3/5. So 32 to the 3/5 equals 8. And that's how you it's a great property in converting back from log to exponents and exponents to logs. And it's kind of a way to show you how the two are interrelated with each other. All right, example 2. We want to express both log base 3 of 81 equals 4 into exponential form, and also negative 2 equals log base 1/3 of 9. Okay, so log base 3 of 81 equals 4, and then negative 2 is equal to log base 1/3 of 9. Okay, so it's kind of, example 2 is just kind of the opposite of example 1. We're going the other way around. But just like I did before, the first thing I did was focus on the base. Here the base is 3. So I'm going to start, that's also going to be my base for the exponential part. So 3, go across the equal sign to get my power. 3 to the 4th equals 81. Okay, on this one, start with our base. Base is 1/3. So 1/3 to what power is going to equal something else. Let's go across your equal sign, negative 2, and come back and grab the 9 is what it's equal to. And let's just check. 3 to the 4th is 3 times 3 times 3 times 3, 81? Looks good, checks out. 1/3 to the negative 2. Okay, remember a negative exponent, nothing else, just tells you to flip your base. So the reciprocal of 1/3 is 3, and 3 squared is 9. So that also checks out. Alright, let's go to the next example. We want to solve log base 4 of x over 3 equals negative 5/2. Okay, alright, with this one of the easiest way to solve an equation that has the log in it, you're like, how can I get rid of the word log? I just don't want it in there. You know, if you had an equation, let's say the square root of x minus 1 equals 3, you know, you want to get rid of the square root sign, so you just square both sides, and that takes care of that. Well, it's like, how do I get rid of the log? Well, the way to get rid of it is to use the properties we just did on examples 1 and 2, is you take it out of logarithmic form and you put it into exponential form. So let's start with that base. The base is 4. Okay. To get the power, you always go across the equal sign. So 4 to the negative 5/2. And then what you were taking the log of, which is x over 3, is what's going to be on the other side. Okay, so it's base, go across the equal sign to get your exponent, and then come back to set it what it's equal to. And then from here, look, we don't have an equation anymore that has logs. We can actually finish solving this. Alright, 4 to the negative 5/2. Well, negative 5/2, you can do one of two things. If I want to make that negative exponent positive, I would take the reciprocal of my base, and that's just saying 1/4 now to the 5/2 power is equal to x over 3. And then anytime you have a fractional power, that's referring to a radical. where the bottom number tells you your type of root. So we're looking at the square root of 1/4, and then that top number, the numerator of your fraction, tells you the power afterwards. To the 5th power then is equal to x over 3. Okay, so again, the bottom number is the type of root, and the top number is your power after your root. So the square root of 1/4, the square root of 1 is 1, of 4 is 2, so 1/2 to the 5th power equals x over 3. Well, distributing my exponent to both the 1 and the 2, 1 to the 5th is 1, 2 to the 5th would be, 2, 4, 8, 16, 32. Would be 32 is equal to x over 3. And the only other thing I have to do to get the x by itself is just multiply both sides by 3, so that way we can get that off that denominator. So x is equal to 3 over 32. Now, I'm going to box that up, but like you can see right here, I have ourselves a little note. We have to check our answers with logs. And the reason why is because if you go back up into your notes for this same lesson, you will see that the domain for logs is from 0 to infinity, or if you want to look at it as x is greater than 0. We can't take a log of a negative number. So if I take 3 over 32 and I plug it back into my equation for x, if I take 3 over 32 and divide it by 3, it's still going to come out positive, so I know this is going to check off. That's all we're concerned with, is when I plug it in, is it going to give me a positive answer number or a negative number? That's all we need to check for, so I know it's good. Alright, so example 4. We want to solve this equation. 4 equals log base 2 of 1 minus 5x. Again, anytime you want to solve an equation that has logs, always just take it out of log form and put it into exponential form. Start with the base. The base is 2. So start there. Go across your equal sign to get the exponent, equals, and then come back to figure out what it's actually equal to. So 1 minus 5x. 2 to the 4th, 2, 4, 8, and 16. Alright, so 16 equals 1 minus 5x. Let's move 1 over. So 15 is equal to negative 5x. Divide both sides by negative 5. And x is equal to negative 3. So let's box that up, but before we actually move on, let's check our answer. If I plug negative 3 into the original equation, I get 1 minus 5 times negative 3. Well, a negative 5 times negative 3 is 15. Add on 1 is 16. We're good to go, because then I'll be taking the log of a positive number. Okay, so hopefully you guys are kind of getting an idea of how really interrelated that both logs and exponents are, especially when solving equations. Really helpful. Alright, this next example, we want to solve an equation. Again, it's in log form. So the first thing we want to do is take it out of log form. Go to your base. So from the base, you go across your equal sign always. So 4 squared is equal to, and we're going to come back. And all of that is what you were taking the log of. So we're going to write all of that down. X squared plus 3x plus 18. Okay, so 16 is equal to x squared plus 3x plus 18. And if we look closely at this, we're like, okay, solving for x is quadratic. The only way to solve for a quadratic equation is to set it equal to 0 and either factor or use a quadratic formula. So I'm going to move the 16 over, so we set it equal to 0. We get x squared plus 3x, 18 minus 16, be a positive 2. And I tend to favor factoring first, so let's try factoring. Set up 2 parentheses with x and x. The factors of 2 that add up to 3 are going to be a positive 2 and a positive 1. So from this first parentheses, I'm going to get x equals negative 2 as a potential answer, and x equals negative 1. Alright, and then we just kind of, like I said, we always want to go back up and check. So if I square negative 2, you'll get 4. 4 and 18 is 22 minus 6 is still going to be positive. So we can check that out. Negative 1. Negative 1 squared is 1. 1 and 18 is 19. 19 minus 3, still positive in there, so we are good to go. Both of those check off, and we can call this problem done. Alright.